Okay, so we would now try to have a look on those track access charging topic from, I would say, an engineering point of view. And I even would add one. I know we have a lot of aspects already that track access charging should cover. But from my point of view, one very important issue is missing. And this I would like to discuss now in this slide. As I mentioned already, the direct cost on the directive parts consists to the overwhelming part of the cost of permanent way, so the track, and they are determined by the wear and tear processes in track. So what are the main influences on the track costs? There is a lot or a variety of aspects that triggering track costs, of course, but I would only choose the technical aspects. So there is one sentence in the regulation that says, is it possible to demonstrate that the values or parameters are significantly different for different parts of its network? Yes, of course. Yes, of course. When we look into track costs, we have different costs for different radii. We have different costs due to different substructures, to different superstructures we use. We have speed level at very high in technical influence. We have turnouts in our networks that are very costly. And of course, we have the transport volume. So if we combine those different technical influences for different track sections, we could very easily show that if we have a line stretch which is curvy, we would have even 3 times higher costs than compared to a straight line. If we have more turnouts on the segments, we would end up with higher costs. And if we compare an old line, not with old infrastructure, but our components, but an old line with its substructure mainly and its radii compared to a new line, which when we construct it now would consider of perfect substructure and probably also slab track, we would see a huge cost difference. So we should, from an engineering point of view, of course, consider that. And that would mean for track access charging, rather a line-based assessment than an assessment of the costs on the basis of the entire network. So this is one aspect from the track point of view. We have those values and parameters that differ, and therefore also the cost significantly differ for parts of the network. Coming back to those different technical aspects, we see all over the place in the track access charging schemes in Europe that they almost skip all these technical influences. We mainly have network-wide valid track access charges that differ with the transport, but not with the infrastructure itself. On the other hand, we should set the costs or the charges on the costs that are directly occurred as a result of operating a train service. Now, from an engineering point of view, what is the train service? In railway operation, we have different trains. We have different train services. So can we really describe this train service with the cost units train kilometers or gross ton kilometers? I have an example for you. Look at those 2 trains. High speed, or at least 200 kilometers per hour train with 300 tons about, compared to a freight train with also 300 tons operated at the speed level of 100 kilometers per hour. Different trains, different vehicles, different axle follows. Do you really believe that these 2 trains lead to equal track costs? Definitely not. So from an engineering point of view, it is a little bit more different. While our legislation talks about the influence of track loading, for the cost causation, it's different. It's not the track loading, it's the specific loading. In track engineering, we talk about wheel-weight interaction forces. We talk about different forces that lead to different damages on rails, on sleepers, on ballast. These forces differ between different vehicle types. They differ with the speed level and they differ with the track properties. So when you combine that, you would need a track model that describes those different processes. And this is not something what we have to search for. There are such models existing. And you see that some of them are used, or two of them are used in track axis charging scheme, and would like to use the Swiss approach as an example. What does that mean, that complicated formula? So in terms of track axis charging and all these organizational topics behind, this might be a very detailed or formula. It's still definitely more complex than taking gross tons and multiply it by a cost figure. But from point of engineering, it is very reduced. What is linked here is the input of the vehicle, and this is the main input for the main processes. So it's the dynamic vertical axle load, which is something different than the weight. We have the axle load, the unsprung mass, and the speed level there. Then we have the applied traction force, the power density that is transferred in the contact patch. So it is a very different thing if you look at the powered axle compared to a non-powered axle. Then we have the stiffness of the bogies and the entire stiffness of the vehicle. This is relevant when we go into the curve. And also for turnouts, maybe the lateral force of the leading wheel on the outside of the. So this is not too much what we use from the vehicle, but we could link that to damage processes in track. So what is happening here? We talk about the ballast iteration, the track geometry payloads. Our main aspect, we have to guarantee a proper track geometry to run and operate our trains. Then we have again the influence of the vertical load and the traction power, which harms the rail surface on straight track or tangent track. This stiffness leads to different effects of the rails and curves. On the one hand, everything that is linked with rolling contact fatigue in wider curves and with rail wear in sharp curves. This goes to the turnout components and the wear of the turnout components. And of all these different wear and damages processes, we have maintenance jobs. And we know how much these maintenance jobs cost. So this is tamping ballast cleaning. This is rail grinding. This is rail grinding in the curve and rail exchange in the curve. And this is, of course, turnout component exchange. And when you follow this engineering approach, you see that we can link on a physical deterioration model some input figures of the vehicle with the track costs. So this is what I see as available cost causation model. If we do that, we see that it is first different for different vehicles. Secondly, it varies with the speed level. And thirdly, it varies with the curve. In Switzerland, we calculated from this formula 10 different prices or charges for one vehicle, differing with speed level and the curve. So how could we implement that? Because this is meant to be a very fancy calculation, but it's not that hard to implement. We could have an option that we have an average price per vehicle. This is a bit done in the UK model. So we would use the network characteristic in terms of curves and the speed distribution for every vehicle, and we would end up with one price per vehicle. This is still a simple solution, and you send out an economic sign to the train operating companies. You remember that, send out an economic sign for rational decision making. So please come with a vehicle, which is, that's called track time vehicle. Billing is quite easy because there's one price for one vehicle. This is not a very fancy software-based system. This is quite easy now. There are some question marks with such an average price. It's technically questionable. Think on a high-speed train, which would be charged in such an average price for a small radius in the network, but it would never run there. So think on that again. You would not generate an incentive to utilize a special vehicle under specific boundary conditions. Not all vehicles would need to have good curving steering equipment, but it would be necessary for those who run on curvy lines. And a very practical aspect, for every new vehicle, you would need to assume a speed distribution for that vehicle. That could be a challenge. Therefore, we could move to another option, which would be a vehicle price, one vehicle, 10 prices, covering the line characteristics and the actual vehicle speed. This model is used in Switzerland for the pricing scheme. So we cover the vehicle properties, we cover the radius of the track, we cover the speed. We cover turnouts as an average. We would not charge for every turnout on the line, but this is added as a surplus. The charges are much more transparent. It's possible to calculate those charges with a very easy equipment for every vehicle you want. And it provides this incentive maybe to use different vehicles of different lines. What we cannot address to now with this model are the characteristics of sub and superstructure. It's not addressed, it's taken as an average. And turnouts are also not covered, as these charges are still applied on a network-wide level, covering the characteristic of the track, but not the specific line. This is the easiest thing to do if you want to move from here to lines, because these cost increments that we discussed before, that could also be calculated, of course, for a specific line, where you could cover also turnout frequency and size. This is something in discussion in Switzerland. They run the system now for already more than 5 years, and we are on the way to discuss to make it even more in detail. That would then be an additional option where we cover all technical influences and additionally vehicle properties. All technical parameters included, The infrastructure manager can also provide the improvement which is done by a track investment or a new line to the train operators. Think on if you have a new line that you construct newly, you would have, due to the high quality that these lines have, low maintenance costs because we invested a lot, so fixed cost, to have low maintenance. And for those lines, we could provide lower charges because maintenance is low there. In our today's schemes, these new lines are added to the average and you would pay the same amount even though those lines have lower maintenance. And of course, it goes hand in hand with total cost transparency. There is not even one aspect of discriminatory prices, as costs are not averaged and they are really linked with the one train service on a specific line. If I could summarize that so far, we could use those track iteration models to provide a very sound basis for calculating those costs with an engineering approach. Remember that best understanding of cost causation. This is the best understanding we have so far. Of course, it goes along with preconditions. We need to have the vehicle data. We need to have detailed track data and detailed cost data. So a lot of data, a lot of good data, because this all models are based on. The interesting thing is these data most likely exist as this is the railways. We know our tracks, we know our trains, we have not running trains on our networks, which we don't know. So we have those data. Probably we have not stored them in the railway. Probably it's not easy in the moment to assess them, but with some changes in data storage, it is available. And the charging system is not more complex than today's ones. It maybe seems to be that way. But we have the possibilities to have the charging calculation and billing computer aided. And sorry for that, but I think that should not be a big deal in times of 4.0 and what we have with big data and so on. So this is a possibility. One big topic whenever we talk about that is this allowed? Allowed is everything that is covered by legislation. And if we look into the implementing regulation, we have an article that covers exactly those different things. So the member states may allow the infra manager to modulate the direct costs, taking into account, and then is the list, the number of vehicles, train mass, the unsprung mass, train speed. So you are allowed to use those different aspects. So yes, it is allowed. This is not the issue. And then always the second question, what for? Why should we do that? And this is a thing that can only be discussed on systems level, not from the perspective or the point of view shifting money from A to B. It depends how you see track access charges. And the main goal or the main aspect of the legislation was to install a market in the railways. And if you have a link, and in this case, the charges are the link, which are prices, in every market, prices will steer. So, look at it from a different point of view. I simplified this is railways. We have a system of masses, springs, and dampers. This is vehicle, the vehicle body, the bogie. Then you have the rail, the wheel, the rail. Then you have another spring to the sleeper, to the ballast, and so on and so forth. So this is the system we have. At least vehicle track interaction. Okay. When we start here, we start with a force. So it's a force that this system generates in the track. When we are on the track infra manager side, this force means something. It triggers processes. So we have inspection. We always look, what does this force mean to our infrastructure? If we see where or a certain state, we would start with maintenance planning. This is what Peter was talking about before. From maintenance planning, which is influenced by the general idea of asset management, we would come to a point that we would execute the maintenance. That could also be a contractor. The contractor would fix the problem. Up to here, this is a technical driven process. Then the contractor bills. So there's the first time we have money. This billing runs through the cost accounting of the infrastructure manager, financing, asset management. This is what the infrastructure manager's daily business is about. On a completely other part of the system, there happens another process. Far away from this process of dealing with our assets. We have customers. Could be passengers, could be a freight shipper. We have customers. The customers ask for a service, a train service, and go to a train operating company. So now this train operating company is doing a business case. To calculate this business case, it is necessary to have a time schedule. When can I run the train? Is it possible to run the train when the customers need it? They need a vehicle, so they go to a vehicle producer to see the vehicle for this train service. And for the time schedule, they have to get in contact with the infrastructure manager, with the train path management. And of course, this business case is linked with costs. So there is a lot of costs involved here. There is costs for the vehicle. This is the high initial costs. There are costs for the train path. This is the track access charge that we're talking about. And of course, there are a lot of other costs like vehicle maintenance and the operation, the staff, and so on and so forth. There is a lot of costs going inside that business case. And then there are the revenues because the customers pay for it. And in the case the train operating company sees that this business case works, so they will make profit, then they would run the train. You might think this is very abstract for track access charging, but it is not. Because track access charging per legislation needs to link those costs for the train path with the cost of maintenance. So are the track access costs, track access charges equal the costs of the maintenance? On average, that might fit. But when we now want to optimize the system, we could do something. We could reduce the force here. So when we reduce the force here, we would have, again, a lot of effects that are cost relevant. The first and probably most important one is when we use a vehicle which reduces forces, it will be more costly. We could reduce the unsprung mass. We could reduce or we could improve the steering of the bogies and so on and so forth. We could use lightweight construction, but this comes not for free. That would be additional costs in the business case of the train operator. But here, we would also generate maintenance savings on both sides, on the vehicle maintenance and on the track maintenance, because we're talking about track and vehicle interaction forces. And if the force is reduced, it will help both the vehicle and so we have reduced costs. For our case of the track access charging, it is interesting if these savings here, the lower costs due to the reduced forces, will make their way into the business case. So run through again cost accounting and stops here at track access charging. Because here we have no system that is dealing with forces. We talk about train kilometers and gross ton kilometers and so on and so forth. So if we have a track access charging scheme that is not dealing with forces, we cannot provide the savings here into the business case. So it's the same. And when you look into this business case, that means the following thing. The business case for a track-friendly vehicle is always negative at the railway undertaking side. So the railway undertaking, from its economic point of view, must decide against the higher quality in the vehicle. There might be some innovation that could be justified with the savings in maintenance on the vehicle itself and the initial costs for the vehicle. But as long as this is linked with the track, we have no possibilities to add the savings on the track side. So this was the case if we think on system optimization. And believe me, it also works the other way around. So if you are not paying for additional wear, for additional damage you do on the track side, you could also think to take a cheaper vehicle, which is more track harming, because you will save, as a train operating company, you would save money from the initial costs and you would not be charged for that. And this is happening. This is happening since 30 years already. So we see due to the splitting of the infrastructure and the train or the vehicle, we see this process of suboptimum at the train operating company. So what for? This is because we need to guarantee the system optimization still in this complex organizational structure. We have with the track access charging no price incentive to use a better vehicle. It is differently. We have a price incentive to simply not care about track damage. So in the end, of course, which is the case, that track costs increase due to the use of track harming vehicles. But in our system, with averaging, we move those additional costs always to all users on our network, because track cost is increasing. So we will see that in our costs, but we cannot link it to the origin of this cost increase. This was probably too pessimistic. No, it is done. We have countries which use such models in their track access charging scheme. We have in Austria a very basic approach of that, which is only valid for traction units, so powered wheels. This is because this model was installed in 2005 already, so a long time ago, where the data situation was not that good to go for a more specific and more detailed model, but still it was there, and it put a sign for train operating companies to take care on what type of vehicle they would use. The incentive, the financial incentive, was not very high, but at least it was there to be considered. When we installed that in 2005, we were convinced that having once put such a system into place, that there would be a lot of infrastructure managers who would follow that kind of approach, but it happened nothing. The next country that installed such charges that were based on a track deterioration model was in the UK. Still on a, would say, simplified level seen from today's point of view, but it was much more detailed than the one used in Austria, and it was applied for all vehicles. Why did that happen? The UK had big problems with their infrastructure and the infrastructure costs. So they were running on a quite low quality in their infrastructure, and therefore they wanted to send out a sign, an economic sign towards the train operating companies. Please, with every reduced loading you provide with your trains, we will make savings and we will share these savings with you. And some years later, say mainly based on these two models that were or have been already installed, the SBB in Switzerland developed this track deterioration model that I used here as an example, and put this into place into the charging scheme with 2017 with this 10 price per vehicle approach, and delivered a billing scheme which covers all regulatory aspects of the track access charging scheme, and there are a lot. Who is providing those specific data for the vehicles? In Switzerland, it is the train operating company itself. It does not deliver those data to the infrastructure manager. The infrastructure manager provides a platform where you have the calculation in, and the train operating companies price in their own vehicle. There is simply a check on that. And they made it possible with all the necessary and available data that you have nowadays to calculate or to depict exactly the way of the vehicle on the network, which track radii are passed, which was the operating speed, and then it's simply multiplying this amount of kilometers with those prices that they. So it works. First, it is done. It works. So it's practically possible. And then there is always discussion on, does it really steer the process? Is it incentive that something changes? And here, we can very easily state we would need more of it. In the UK and in Switzerland, we have, in the UK we have probably a special situation because this is an island and it's not too much linked to the railway system. But in Switzerland, we have two parts. This is the passenger transportation, which is a national market. So here we see already from what is done with the vehicle that this incentive works. So there are retrofitting processes, applying features on existing vehicles to get more track friendly, or in this case, as the train operating companies do not care about track friendliness or not, to reach a lower level of track access charges. And this is something that can be changed immediately. The more important thing is when you look into the future, because the biggest, of course, the biggest effect you have when you design a vehicle, when you can still influence transport masses, axle loads, and so on and so forth. The second part is the mainly international freight operation. And of course, when you run a freight train from Rotterdam to Naples, the part that you pass in Switzerland is a very short one. And therefore, these incentives would not really affect these trains operated there. Therefore, it would be necessary to enlarge the parts of the railway, the European railway network, where we have such models in place. Again, would be a topic of harmonization. If you just remember what I said in the first presentation about the different possibilities, I mentioned that the legislation allows for such models, but it's not obligatory. So as long as you can, as it's allowed, you can apply it. But the best incentive, of course, would be given if we have these models in place in various countries. Still, I would like to mention that because this is one-to-one discussion with every single infrastructure manager who's interested in such a model. They always come with this international argument. We have one very interesting application also in track access charging, where we could see that this also steers on another level. That was with the noise charging, which was applied in Switzerland very early, while the European Union, with all their processes, I think it needed 10 more years in Europe to come up with noise charging for freight wagons. But in Switzerland, they took the profit, because from the international freight trains, the train operators, of course, use their less noisy wagons in Switzerland because they get a bonus there. So it steers even a little bit on that international level, but of course it would need more and precise calculation on that. This is done in research on European level. It is done. There is a model that was developed in a shift to rail project recently, not with the focus on using it in track access charging, but with the focus on evaluate different vehicle innovations on a system level. So the models are existing. We still hope that these models will find their way into the track access charging from two different aspects. From my perspective, maybe three. So this is to lower the entire system costs by a better and agreed link between vehicles and track. The second would be transparency and equal and fair distribution of the costs. When I started to deal with these models, one thing I learned from the very beginning, in our European railway system, we shift much too much costs to the freight operation. So this is overfinancing the infrastructure, which does not really help the freight operation on railways. We have other systems in place where we give aid to rail freight operation that would not be necessary if we simply calculated in the right way. And the third thing is, of course, from my point of view, from track asset management, we need to consider, we need to use those kind of approaches to optimize the maintenance processes. And if we still have it, we can, could, and should provide these models within the infrastructure managers, also to the departments with the track path allocation and the track access charging. And here I would like to stop and ask for your question, for your discussions, or probably inputs. And yes, you will also get these slides, of course. Do you have questions?
Let me give you a comment to the point. The European system separated the railways into two: infrastructure and maintenance, and said the market will steer everything, and the market steers, but the market steers via prices. And as long as we have wrong prices, we have wrong steering. And this example very well worked in Europe. We can look it. We see that the driving qualities of the newer rolling stock is poorer than it already was. I think to put in prices which are justified, economically justified, and technically, and then it goes to VNT, is nothing else than to learn to live with the new system. In that point, we did not learn up to now to handle the new system. And that's a very short and very bad word, which my comment to the track access charges.